Aloha class, here we are. Let's go. Give me them toes. 2017, right? We did in class 2019, we did in class 2018. So let's go. Today the video is the 3 questions, tree, that would be be on the AB and the BC exam. So let's start with question 1. Question 1 was in 2017. It was on both exams. Obviously, question ichi means that it is calculatora, okay? So here we go. Graphing calculators are required for these questions. A tank. Oh, let me show you this, guys. Not that, but this. Not that, but this. Okay. Texas Instruments has thrown out this thing here where you can get free software. So you can download the 84 Plus to your Chromebook, or they even have some TI Inspires for the iPad, and they're doing this for the next 6 months of these free subscriptions. So hook it up, no excuses. All right, here we go. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank is given by the function A of h, which is this table right here, and it's measured in square feet. The function A is continuous, and it decreases as h increases. So it's a decreasing function, and it's strictly decreasing. Selected values of A of h are given in the table above. Okay, use a left Riemann cell MRAM, LRAM, LRAM with 3 subintervals indicated by the data in the table. Okay, so what they're asking us is they're asking us to find the volume of the tank. So what that would mean, and you guys all know I have my ghetto pen, but we're going to give it a shot here, right? So we're going to go booyah. All right, so we're going to do for part A here, we are going to do the integral, right? Because we're going to go volume is equal to the integral, and it said from 0 to 10. If I look up there, right? You guys can always pause the screen. Oh, shame on me. Everybody hit pause right now and try it on your own, and let's see how you do, okay? But let's go back up here. And after you've hit pause, it says from 0 to 10. Okay, from 0 to 10 feet. And what we're going to do is we're going to take the, remember the volume is the area of a cross section. So we're going to take the area of this, and we're going to multiply it by its thickness. And they asked me to use LRAM for this bad boy, okay? So we're going to have to go back to the table up here and check out the values. So my first one would be from a height of 0 to 2. So it'd be 2 times 50.3, right? So it'd be 2 times 50.3, and I really hope you guys tried this on your own. All right, and we're not going to try to make these videos so crazy, right? I got to keep on going up and down, but we're going to do plus dot 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 plus, right? And we're going to do that for all of ours, and let's see if you got it right, okay? So I'm going to go here to our grading page, and let's try not to look too far ahead, all right? But if you've got 176.3 and it asks you for units, okay, so if you think about this, if we go back to my work here, this right here, right, class, this would be in square feet, right? And this right here would be in feet. So if I do square feet and feet, I got tree, right? I got cubic feet. So you're going to get a point. But the interesting thing about this one, if you look at the grading here, okay, look at that grading, you get 1 point for the units of A, C, and D, because it asks for units for each one of those parts, okay? So see if that was good. See if you were able to do that correctly, okay? All right, and then here we go. Let's go back to the next one, all right? And remember, when I read a question, I'm going to make sure I say hit pause, and make sure you hit pause so you guys can see how you would do, okay? All right, let's look at the next one. And you guys all know, if you don't like my going up and down, you can get this on your own computer screen, right? The question is 2017. All right, does the approximation in part A, is that an overestimate or an underestimate for the actual volume in the tank? Explain your reasoning. Okay, hit that pause button, okay? Write down what you think it is, all right? And then here we go. What do you think this would be? Well, it said earlier right here that it decreases. Okay, so that's a strictly decreasing function. So if I was to graph it, it would look like that, right, class? So if I was to do a little LRAM, right, that means we use the left side, and every single one of my rectangles, right, are going to be, ooh, this is a little ghetto, but they're all going to be an over. It's all going to be over the line. So guess what? It's going to be an overestimate, right, class? So let's go back here and let's see how many points you guys have accumulated, okay? And it looks like right here that The approximation in part A, don't look ahead, sorry, is a overestimate because a left Riemann sum and A is used and A is decreasing. Overestimate with a reason. So make sure you give the reason that, since it's a decreasing function, heck, I would even draw out a picture, right? If it was the AP exam, and do exactly what I did on that screen ahead of time, all right? I'm sure you guys are dominating, so let's keep on going. All right, let's roll. Let's check out part C. Part C says the area in square feet of the horizontal cross-section at height h feet is modeled by the function f. So we have a brand new function now, right? Earlier it was a, now we're dealing with a function f. And it's given by f of h equals blah, 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 blah. Based on this model, find the volume of the tank. So we're talking about a different tank right now. But instead of giving me a table of values and asking me to use LRAM, oh yeah, hit pause and do it. Okay, so instead of giving me a table and giving me an option of LRAM to estimate the volume, they actually give me a function here, okay? And they say that that is the horizontal cross-section. So we all know, well, hey, if I just know the cross-section in feet, all I need to do to find the value, and we're still gonna go from 0 to 10, right? Because that's the amount of time that has elapsed. But for this one here, I'm just a little f of h dh. How about that? And then all I have to do is calculate that bad boy, and that's going to give me the volume of the tank. That's all I need to do. And guess what? You guys are all going to have this option now, right? Go ahead and download that bad boy. I'm not going to do it because this is probably an okay one, and you guys probably already did it already at home. Okay? So I'm just going to go over here to the gradient, and let's see how many points we got for that guy, right? So we go 0 to 10. Don't look ahead. I got 101.325, and that's 325 if it's truncated, or if that bad boy's rounded. You get 2 points for that. So far it's 1, 2, 3, 4, 5, 6 points. And remember, anything bigger than a 4, you're jamming it, killing it. All right, here we go. Let's get this first question one done here. All right, let's go ahead and erase that. And here we go. D, water is pumped into the tank when the height of the water is 5 feet. Whew. So the height of the water is 5 feet. Let's check this out. So H is, I'm going to start writing down important stuff. H, because that's what Mr. Tanaka told me to do. Actually hit pause. Try it on your own. Okay, unpause. H equals 5. The height is increasing at a rate. Ooh, it's increasing. That means, ooh, this looks like a related rates type of question, right, class? So dH dt equals 0.26. Okay. I'm using the model from part C, so we're going to use this model here from part C. Find the rate. Ooh, so rate means derivative at which the volume of the water is changing. Ooh, so we want to find dV dt, right? That's what we're trying to do, right? Trying to find the rate that the volume is changing when the height is 5, right? So we would use to star that little h equals 5 because you're not allowed to use that bad boy until after you find the derivative. Remember, always find the derivative. Check out. Let's go get it. Let's get focused for this. Let's get focused. All right, here we go. Let's get focused because this one's probably worth 3 points. All right. Whew. So it says to use this up here. So, all right, let's go ahead. I could create a little problem here. And I've got that volume is equal to that up there, but it's from 0 to h, right? Because we don't know what the time is. F of h dH. Okay, so it says to find the rate that the volume of the water is changing. And I can plug in a 5 after I find the derivative. So let's find the derivative of everything here. So we have dV dt, because that's the derivative of v, right? It'd be 1 technically dV dt. Now I'm going to take the derivative of an antiderivative. And remember, ooh, I should technically use different variables here, right, class? Okay. So I'm going to find the derivative of an antiderivative, which means I'm just going to plug that bad boy in. And remember, I technically would have to chain that h, right? What's the derivative of h? It's ichi. But then remember, this is a related rates question. So everything is with respect to time. So then I better add a dh dt to this guy, right? And then the question is, hey, could I finish this? Well, I'm kind of running out of room right here, but let's see what we can do. I can now plug in that 5. Oh, and I can plug in the 0.6. So I have a little dv dt, okay, when h is equal to 5. All right, and so that means it's f of 5. Well, what the heck is f of 5? And dH dt is 0.26. Well, guess what? F of 5 is just plugging a 5 into that guy right there. And now you got your free calculator, right, on your Chromebooks. And so all you need to do for that bad boy is plug it into the calculator. right? And then let's see if we got the right answer at home. Boom. Sweet. 1.695, right? When h equals 5, remember, get used to writing these as just sentences at the end when you get an answer. When h equals 5, the volume of the water is changing at a rate of 1.695 cubic feet per minute. So this one was careful. I always tell you guys in class to just write your units, whether they ask for it or not, because it would have been easy to forget units, okay? All right, I'm going to look at what the next ABBC question is, and I will be right back at ya. All right, class, here we go. No calculator is allowed for these questions. We're on question 3 now because 3 was the next one. And guess what? I know you guys want to do well in this AP, so I'm just going to have you do 2 questions today. All right, and I'll just keep on rolling these out. And yes, I expect you to be doing it every day. We all need that outlet, so let's go. Example 3, and I know we struggle with this one, okay? So remember, always hit pause and see how you do on your own, and then we'll see how we do together, right? So we have our little graph here. That's the graph of f prime, right? So that's the derivative. So that just means, I can find the area underneath that, which would bring up that integral guy, right? That'd be the area underneath the curve. Okay, and that's the first thought you should think of when you're looking at a question like this, all right? And the AP loves these bad boys. Okay, so we have f, it's a differentiable function. We're on the closed interval from -6 to 5, all right? Here we go, boom, this dude is important, right? It's an initial value that they give me. We're gonna have to use that in some way, shape, or form. Okay, remember, I think I have a better way of doing these than the AP shows you, so make sure we follow and go ahead and use my methods, okay? The graph of f prime, the derivative consists of a semicircle, 3 line segments, blah, 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 blah. Okay, find the values of f of -6 and f of 5. Pause. All right. Let's see how you guys attempted this one. All right, f of -6, and I want to relate this to this initial value guy they gave me here. And I don't want to go backwards, so I'm going to want to go forward. So I'm going to set up an integral. Why am I setting it up an integral? Because we all know that we could do this and find the area, right? And I'm going to go from -6 to -2, right? Because that's going in the right order, and I'm not going to have to think backwards or anything like that. Well, if I do it that way, then that means gosh darn it, I could actually find the answer of that. Well, how can you find the answer of that? Well, it is just the area from the curve to the x-axis, and I got to go all the way to -2. Oh, just to there. Easy peasy, jabon easy, because that's just a 1/2 a base, which is 4, times a height, which is knee. And if I do all that, I get 4, right? Sling, 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 sling. And I get 4. So that answers to 4. So how could I use this to my benefit? Well, let's go blue. And the antiderivative of that is just f of x from -6 to -2. And that's got to be equal to 4. All right, so let's go ahead and plug in my value. So it'll be f of -2 minus f of -6. And that's equal to 4. And then f of -2 is savon, right? Savon in French. Right? And then we get this guy, and that's what they're asking me to find. Best way to do these problems. Subtract that savon, and we get negative. Hopefully I didn't make a mistake. If I did, too bad, And we get tree. Okay, so I get 3, and then we'll look in a little bit to see if I got the answer right. Okay, I cheated. I just looked back, and I got it right. All right, we got one more to go, though, f of 5. If you got f of -6 wrong, hit pause and try f of 5 and use the same techniques I just did, right? What do I mean by the same techniques? Let's go. I'm going to use that, and I'm going to use this. Okay, going in the correct order, I'm going to go the integral from -2 to 5, right, of f of x dx. And believe it or not, I can find out what that is equal to, right? -2, ooh, I got a little semicircle. And I'm going to go all the way to 5. Well, this triangle would be 1/2. Oh my gosh, Prince just came on. 1/2, the base is 3, the height is 2, swing, swing, and I get an answer of 3, but I also have a semicircle there, which is 1/2 of a circle, and it'd be pi r squared. That'd be 2, radius would be 2 squared, swing, swing, and I get a little 2 pi, but it's underneath, so I'm going to have to go negative. So my answer would be 3 minus 2 pi. Darling, I would die for you. Prince is legit. Look it up, right? Do a little Spotify Prince greatest hits. That's who your teacher listened to back in the day when I was your age. All right, here we go. So what do I have to do here? Okay, ooh, shame on me. That's got to have a swing right there, right? The derivative of f prime, because if I take the antiderivative of that, I just get f. right? And that's going to be evaluated from -2 to 5. And guess what? That answer is 3 minus 2 pi. So let's go. It's going to be f of 5 minus f of -2 equals 3 minus 2 pi. You should get rid of that stuff. I'm going to substitute in a 7 for that. So I get f of 5. This is how we just got to do it, class. I don't have much room here. Sorry. So it'd be -7 equals 3 minus 2 pi. Let's add that 7 over, right? And you get 10 minus 2 pi. Please be right. Let's check it out. All right. Remember, just look at this first part here. Boom, 10 minus 2 pi. It's right. 3 was right. Guess what? You got 3 points if you got all that right. So the AP says that this problem right here is very, very important when it makes it worth 3 points. All right. So if you're not good, go back and try it again. All right. Look at that messiness. Let's get rid of that B. All right. On the, okay. Now we want to say on what intervals is F increasing? Justify your answer. Hit pause. All right. All right, so we all know that if we're dealing with an increasing, I want to use this color right here. This is a little purple. All right, so if we want to know whether or not F is increasing, well, we all know that this right here is F prime, right, class? And if I want to know if F is increasing, I'd find the derivative, and shoot, it gave me the derivative. And I would do a sign analysis for the derivative. Well, the derivative they already gave me. Usually, right, we find the derivative, we set it equal to 0, and we find out when it could be dne, when it could be 0. All right, so when is this derivative right here, 0 or dne? Well, the derivative is 0 at -2, and it's also 0 at 2, and it's also 0 at the end at 5. Okay, and then if I look, the derivative is positive here, it's negative here, and it's positive there. So if I wanted to say, hey, this is, remember, this is actually let's make it red. This is what the actual graph of F would look like. F would increase until it got to there, then it would decrease, then it would increase, right? So that would be a max, that would be a min, that would actually be a min at that endpoint, that would actually be a max at that endpoint, right? And what's this asking me? When is it increasing? Oh, easy peasy, Japonazy, right? So it's increasing from, we're going to go -6 to -2, and it's union from 2 to 5. And then remember, we have to give a reason for this because they're asking me. And so you could say F prime is positive. That's it, right? That's all you would have to say. The graph of F prime is positive. And that's how we know that the original function would be increasing. Let's go ahead and look at the grading for that. And it says F prime is greater than 0 on those intervals, and that's why it's increasing. So exactly what I said. Now remember, we talked about this earlier, okay? Since we have endpoints, some people believe in brackets, but you could use parentheses there and you would get full credit, all right? So far, you get those two things right. You got 5 go points. You are dominating this exam so far. All right, let's keep rolling. All right, let's see what's next here. C, find the, okay, now this is the one we all kind of struggle with in class, right? Find the absolute minimum value on the closed interval from -6 to 5, and we have to justify our answer. All right, so where should I do my work for this? I should have left up what I had up there, right, class? Because if I want to find an absolute min or max, I have to find the derivative. I have to put the critical points on that bad boy. And we had 2 and we had 5. And then we had positive, negative, positive, boom, boom, boom. So if we look very carefully at that, this could be my minimum or this could be my minimum. Okay, so remember, what we like to do in these problems when we do the absolute is we like to do a table of values. Do you remember that? So let's go ahead and do a table of values. My table of values would be my x values, right? And what are my points? Well, I could put -2 up there, but -2 just shows that that would be a max and that would be a max. So all I really need here is my endpoints, okay? And then f of x, right? Because I just want to know the value. The other critical point that could work would be 2, and the other one would be 5, but we all know 5 can't be it because that would be a max, right, class? So all I really need to know is what f of -6 is and what f of 2 is. Okay. All right, well, what the heck is f of -6? Well, believe it or not, we found that in part A, right? And if I'm not mistaken, that answer was 3. All right, now I have to find out what the answer of f of 2 is. So I'm going to have to do a little bit of work, kind of like what we did earlier. Okay, so let's see. Let's find out what is f of 2. In order to find out what f of 2 is, I got to do this little thing again. I've got to go the integral from negative 2 to 2, right? And why use negative 2? Once again, that was what was given to me of f prime of x dx. And let's see what that is. Well, that's just from there to there. And we know what that answer is, right, class? That answer is, we did it earlier. That's just, oh, that's just my circle. 1/2 would be negative, what do we get? We get negative 2 pi, right? Because it's 1/2 pi r squared, and we did that earlier. And so here we go. We're going to go ahead and find the antiderivative of that bad boy, plug in, use the fundamental theorem of calculus, right? Let's go ahead and do this work. We get f of 2 minus f of negative 2 equals negative 2 pi. That is 7, and then I'm going to add it over. So I get 7 minus 2 pi. Now, you could plug in these other values. You could actually find that right there. We already know that that answer is 7, right? That's not the answer. So our answer, our absolute minimum value would be between those two. And the question is, what's smaller? And this is non-calculator, but we all know pi is approximately 3. So that's like 2 times 3, which would be 6. 7 minus 6, right? That's ichi. And it's actually even smaller than ichi. So this would 100% be my absolute min. And it says value. So since it says value, remember, it's asking for this answer right there. And we're going to justify our answer. Remember, we always justify it by your table. Whenever we ask for absolute mins or maxes, it means you have to check endpoints. Let's see how we did. There it is. Booyah. I am money today. Perfect. Who wants to shoot a jumper for that from the wall? I'm going to have to figure out a wall shot. Come back tomorrow to find out what it's going to be. Maybe I'll have my son see if he can knock it down. All right, so this one's only worth 2 points. You had to consider x equals 2, and then you have your answer with your justification, which is the table, right? And they used all those values. But if you explained why you didn't have to use negative 2, why you didn't have to use the endpoint of 5, you'd be good to go, right? Because those would be maxes. There's no chance that those could actually be absolute mins because they're not mins. All right, here we go. One more to go here for today, and then we're going to call it. I really hope you guys will do these problems. I'm working hard for you. Work hard for me. Work hard for you. Work hard for everybody. All right, D. Oh, we're going a little second derivative on us here. All right. Find the value or explain why it does not exist. All right, let's go ahead and check this guy out. Well, let's relate it all to our problem. Correct? Well, we have this guy here. Well, why would I do that? Not going to do that. It's just a second derivative. Second derivative of negative 5, which means it's just the slope of this guy. So what's the slope at negative 5? The slope at negative 5 would be right there. It'd be whatever the slope of this line right here would be, right? Because negative 5 is right there. And so if I look, what is that? That looks like we go down 2 and this way 4. So what's down 2 and 4 to the right, right? Do I have 4 to the right? I do have 4 to the right. So it'd be negative 1/2. There you go. That's my value. Okay, let's do f double prime of tree. Oh, sweet pointy place, right? And there's a pointy place right there. If it's a pointy place, that's DNE. You know, and it does not exist. Why? It's a pointy place. Or you could even get a little crazier, and we talk about slopes. The slope, and remember, would be a limit. Okay, would it be a limit as we approach 3 from the left? F prime of x is positive, right? The limit as we approach 3 from the right of f prime of x, well, that's negative, right? And so, I should have a double prime there, a double prime, because that's what we're checking, right? We're checking the slopes. So you have a positive slope, you have a negative slope. So if those slopes aren't the same, then you get a little DNE. Let's see what the AP made us do for that one, okay? To get full credit. Let's go ahead and look right here. You have f, it was negative 1/2. Ooh, so they actually do. Whew, it looks like pointy place maybe wouldn't have worked right there, right? So we actually see they did do the limits. Okay, but you could have did what I did earlier and just said the second derivative, right? Which would be the slopes. And one we get positive, one we get negative. But you know what? It is important to look at what they did. Okay, they went ahead and they set up these limits. They actually did it, and they found the rise over the run. When you do it from the left-hand side, right? What they did is they actually just found this guy's slope. Okay, which would be up 3/1. Okay, right, up 3/1. You see that? Up 2/1. Okay, was it up 2? Oh yeah, up 2/1. And then they found the slope of this. What is that one? That's down 2/2. So that's how they get a -1. So you know what? In the future, shame on you, Mr. Type. We got to show a little bit more work on that, it looks like, right? To show exactly why it does not exist. It looks like that pointy place isn't going to work unless it was multiple choice MC. All right, aloha, homie homes. Let's check it out. Let's get one bucket in for today, just for good measure, right? There's the hoop. There's the hoop. Check it out. Homie homes. Is he good? Shbling. It's kind of stuck up there. All right. Aloha. It was good seeing you guys. I can't tell you how much I miss you. You know what I would appreciate? Make a little video of you doing some math. Send it to me. I miss all you guys. Aloha.